A venturimeter with 150 mm diameter at inlet and 100 mm at throat is laid with its axis horizontal and is used for measuring the flow of oil of specific gravity 0.9. The oil mercury differential manometer shows a gauge difference of 200 mm. Calculate the discharge. Assume the coefficient of discharge of meter as 0.98. Given problem is venturimeter problem. Venturimeter. So venturimeter is used for measurement of discharge or flow rate of fluid. So first of all, note down the given data. Here diameter of inlet. Diameter of inlet D1 is equals to 150 mm. Convert 150 mm into meters. So 150 mm means 150 by 1000 meters. 150 by 1000 0.15 meters. So diameter of inlet is 0.15 meters. Next, diameter of throat. Diameter of throat. D2 is equal to 100 mm. 100 mm means 100 by 1000 into meters. So 0.1 meters. Next, specific gravity of oil. Specific gravity of oil. Specific gravity of oil S suffix oil is equal to 0.9. The oil mercury differential manometer shows a gauge pressure of 200 mm. So reading of oil mercury differential manometer is given. Differential manometer denoted by small x is equals to how much? 200 mm. 200 mm. So 200 mm means 200 by 1000 meters, 0.2 meters. Coefficient of discharge of meter is taken as 0.98. Ultimately, we need discharge Q. Discharge through venturimeter. Discharge denoted by capital Q. To find discharge, we have a formula for venturimeter. Discharge through venturimeter is given by Q is equal to CD into A1 A2 root over 2GH by root over A1 square minus A2 square. A1 square minus A2 square. Now we are going to use this formula to find discharge through venturimeter. Here CD means coefficient of discharge 0.98. A1 A2. A1 means area of inlet. A2 means area of throat. Area of throat. So what about H? In this formula, H means differential head or pressure head. Differential head or another name is pressure head. Differential head or pressure head. So differential head is equals to formula X into SHG by S oil minus 1. So specific gravity of heavier liquid by lighter liquid minus 1. Let us find one by one. A1. A1 means area of inlet. So cross section of inlet is circular cross section. So A1 is equal to pi by 4 into D1 whole square. D1 means diameter at inlet. Pi by 4. Diameter is 0.15 whole square. Similarly, A2 is equal to area at throat. So throat cross section is circular cross section. So we can write D2 whole square. Pi by 4 into D2 how much? 0.1 whole square. Now use scientific calculator to find values of these two. You will get approximately 0.0177 meter square and here 0.00785 meter square. Next we need manometric head or differential head. H is equals to X into X value how much? Reading of oil mercury differential manometer is 200 mm or 0.2 meters into SHG means specific gravity of mercury 13.6, specific gravity of oil 0.9 minus 1. 0.2 into 13.6 by 0.9, 15.12 minus 1. 15.12 minus 1, 14.12. 0.2 into 14.12 is approximately 2.83 meters of oil. Therefore, H is equals to differential head or manometric head. H is equals to 0.83 meter of oil. And area at inlet 0.0177 meter square. Area of throat 0.00785 meter square. Now, substitute all the values in this formula. We get discharge. Discharge Q is equal to CD 0.98 into A1 area at inlet. We got 0.0177 into A2 0.00785 into root over 2GH. 2 into G means acceleration due to gravity 9.81 into H 2.83 whole divided by root over A1 square 0.0177 whole square minus A2 square 0.00785 whole square. Use scientific calculator. 0.98 into 0.0177 into 0.00785 into root over 2 into 9.81 into 2.83. So we have to calculate value of numerator. Before that, 0.98 into, if you multiply these two areas A1 and A2, you will get around 1.3894 into 10 to the power of minus 4 into root over. So 2 into 9.81 into 2.83 whole divided by root over. If you simplify 0.0177 whole square minus 0.00785 whole square, you will get approximately 2.517 into 10 to the power of minus 4. Next, Q is equal to, multiply these two, 0.98 and this. You will get 1.362 into 10 to the power of minus 4 into square root of this value is approximately 7.4515 divided by 0.2.517 into 10 to the power of minus 4. Q is equal to, now multiply numerator values. Here I got 0.00101,489 divided by square root of this value is, in denominator square root of this value is 0.01586. Now calculate this expression. You will get approximately 0.06399 meter cube per second. Therefore, discharge through venturimeter is 0.06399 meter cube per second.